All right, so now we're going to try this without looking at Desmos to get a good picture of it from ourselves. So first we're going to plug it in our TI to get a graph, and then we're going to hit Zoom 6, which is our standard window. Most of the stuff they give us will fit within there. And there it is. And so we only want greater than 0. That's our restriction. So if we go back in and we put in 0 and then hit graph, there is our picture. And now we're going to rotate this about the x-axis. So let's graph this to get our picture. So we have that right there. And then we have our cube at 5. And now if you remember all of our parent functions, at 8, if you remember all of our parent functions, you can actually graph these very, very quickly. So this one's at 4. And then again, it's down 2 over 1. I'm going to do it in red. Right there. That's where they intersect. All right, and we can use our calculator to verify it's 2. If you hit trace and 2 and hit enter, you'll see it says blue. And if we do it again, but this time selecting the red and hit 2, you can see they also hit at 0. So they're entering at 2, 0. That's where they intersect. So we're going from 0 to 2. So let's mark that. So 2 and 0. And we're rotating this about the x-axis. So if we're using disk or washer and we rotate about the x-axis, that means our rectangle needs to be vertical. We're always perpendicular for disk and washer, perpendicular with the axis of rotation. So that's x equals, dx, and that's y equals. So our top one is our negative x cubed plus 8. And let's put that in blue since it is the top. And the bottom is the red, which is the negative 2x plus 4. And so why am I doing this? So that we can know which is the smaller radius and which is the larger radius. So if we draw our disk, we now know that the blue is the big radius, which is negative x cubed plus 8. And the red is the smaller radius, which is negative 2x plus 4. So we can then say our area is pi big R squared minus little r squared, and just plug it in. So our big R is the blue, so negative x cubed plus 8 squared, minus our little r, which is negative 2x plus 4 squared. And now we have our area. And what's the thickness of our area? dx. So we know our volume is going to be pi, and then negative x cubed plus 8 squared minus negative 2x plus 4 squared. And we want to find the thickness, which is dx. It's written right there. And our little rectangle is going to go through all the way through our function from here to here. So I'm going to draw that inner one and that outer one. Oops. I'm going to go a little bit larger there. Down here 8 and then back. And I will draw that outer one as well. Down here. And then we just trace that back. And so that is our solid there. Not the best picture, but you get the idea. And we're going from 0 to 2. So plugging this in our calculator will give us our answer. And so we get 1504 over 21 pi for our volume. So that solid will have that volume. Now let's look at Desmos just to make sure. So here's our shape. And so if I keep rotating it, you can see that's the solid it's making. It's right there. I'm going to leave it there because it's really difficult to see otherwise. You can see the hollow part on the inside. There's our little cross section. And so there's our disk going through the entire thing. So we made one washer right there. With the outer radius is our x cubed. And the inner radius is our line, and it gave us our formula, and there we go. All right, so now let's try one and rotate it about the y-axis. So the same thing with this, but rotating it about the y-axis. So first thing we need to do is graph it. I'm going to do a calculator first, and then by hand, because this is not too bad by hand. So there's what our graph will look like. So to do that, you have to break up the x equals y squared into a square root of x and a negative square root of x, because this needs to be y equals. And the other one is x minus 2. So if we hit Zoom 6, there is our graph right there. So we're going to do this by hand as well, but that's the picture that we need. So we draw this. So the other one's a line, so it's just down to up 1 over 1. So we go there, and there, and there, and then that's our line. And then the other one's y squared, so it's just a parabola. And I know it's going to intersect there because of our picture. But there's another way you should be able to tell that it intersects there as well. I'm going to move that line towards just there, and that's because we're supposed to be setting these equal. So you already know that our rectangle is supposed to be horizontal and have a dy and x equals because we're rotating this about the y-axis. If you rotate it about the y-axis, then we need to make sure that our rectangle is perpendicular to the y-axis. So that means everything needs to be solved for x equals. That's what we need. So if you look at our two equations, the first one's good to go. That one says x equals y squared. Let's actually put that one in the right color. That would be x equals y squared. But the other one isn't. This one, it says y equals x minus 2. So what we need to do is solve it. So if we do, that's x equals y minus 2. Now that they're solved for x, we can set them equal. And there you have it. So y squared minus y plus 2 equals 0. And so we end up with y equals negative 1 and y equals 2. So those were the two values that they intersected at. See? So that's how you can also tell that they're there. So now, looking at that, you already know that your integral is going to go from negative 1 to 2 because that is between your dy. Your dy is between those. So as it transfers from here to here, you can just see that dy moving all the way up here. And so we put a dy here. And then we also know it's got to be a pi here because our area is going to be pi big R squared minus little r squared. So all we need now is our washer. So if I rotate it and rotate it, there's my washer. Let's do the whole thing, by the way. So again, it's just going to mirror image that over to here so you can see it. And then this one would do the same thing. So you can see it's got this like a inverted cone kind of thing. It's like a tornado going on like that. There we go. That's better. All right, so there's our shape. Now we need our disc, our washer, I mean. So inner radius, outer radius, and now we just have to look at the rectangle to see which is the bigger one. So the outer one is the red. And what was that one? That was the y minus 2x, see, y minus 2. So every single time we solve these for x, we're ready to go. The inner one was the y squared. So now we know that the outer radius is y minus 2. And the inner radius is y squared based on what it is. So you can see that little circle right there hits the y squared. And the outer circle hits the y minus 2. So now we can just plug them in. So y minus 2 squared minus, and then y squared squared. So that's y to the fourth. We'll leave it the way it is though, just because. So this is y minus 2 squared minus y squared squared. And you can also simplify it and do it all by hand, but again, I want to make sure that you know what you're doing, so just use your calculator at this point. So plugging it in our calculator, we get 12/5, which would be 12/5 pi.